today we will see how do we graph tangent functions. We're not really going to graph, we're going to be making much of a sketch because we're not going to go too much into detail, but we're going to be sketching tangent functions. Now, the main idea here is that we will be using two properties in order to sketch a tangent function, and that is the period, which is going to change a little bit, you will see. And then we're going to find what is called a vertical slope. A vertical slope is basically just a line that is vertically. And you can think of the vertical slope as some kind of a border. The vertical slope, you can think of it as a vertical border. So now, let's actually see how we can graph tangent functions now. But just keep in mind that we were going to be graphing tangents. We're going to be using the period and something called vertical slope, where the vertical slope you can think about as some kind of a vertical border. So now here's some key ideas here. Notice the first thing here is that if we're going to be graphing tangent, our period is going to change a little bit, because when we talked about sine and cosine functions, we noticed that the period that we were using here, it was 2 pi over b. But now it's going to change a little bit if we're going to talk about tangent. For tangent, the period is going to change a little bit. The period is not 2 pi over b anymore, but it's just pi over the absolute value of b. So that changes a little bit. So if you gotta be careful now. What is that we're graphing? If we're graphing sine or cosine, then the period is 2 pi over b. If we're graphing tangent, then the period is pi over absolute value of b. So now here's how we're gonna find vertical asymptotes for tangent functions. And the vertical asymptote we're gonna find it as pi over 2 absolute value of b. And again, vertical asymptote, you can think about it as some kind of a vertical border. And you will see what I mean by that. So if we're going to talk about tangent, we're going to be using these two properties here. If you want to sketch a tangent function, you got to find these two properties. You need to know the period, and you need to know the vertical asymptote. So let's sketch some graphs now. Again, what you need to know is the period and the vertical asymptote. So let's write our equations again here. Again, for the period, like it was mentioned, the period here is going to be located as pi over absolute value of b. So let's see. Want to find the period of the function? Well, pi remains pi divided by, now what is b? B still remains the same, is the number inside the function, which is 2. So now becomes pi over the absolute value of 2, which this is nothing more than just pi over 2. Because the absolute value of 2 is positive 2, so that's what we have here. Now for the vertical asymptote, we know that the vertical asymptote, you can locate the vertical asymptote by finding 2 pi over the absolute value of b. But we found that b, we found b to be 2. So now this becomes pi divided by 2 divided by 2 absolute value of 2. which becomes pi. The absolute value of 2 is 2. 2 times 2, so that's 4. Now that we have these properties here, now we're okay. Now we can start graphing. Now, when it comes to sketching a tangent function, we always start with finding the vertical asymptotes here. Here, I'm going to say that each 2 squares, that's a pi over 4. So 2 squares to the right is pi over 4. 2 squares to the left from the origin, that's negative pi over 4. It is at this point where we're going to be graphing the vertical asymptote. And again, the vertical asymptote, you're just going to graph a dotted line. At those 2 points. Oops. And the tangent is going to pass by the origin, and the tangent function is always going to start this way. It's always going to look this way. Pass to the origin, and then it just shifts sides. Now, right now, we're just graphing one cycle. We're just interested in one cycle. Because we're just sketching. We're just looking as to what's the shape of it. But again, all you need to know is just the period and the vertical asymptote. The vertical asymptote is that line. And now, this is why I was calling it a vertical border, because your graph is going to be inside this function, inside this interval. And your graph cannot pass those points. If you graph a tangent function this way, which let's do it in orange, let's say you start this graph here, and it passes the origin, and then it passes, then that's considered wrong because your graph cannot pass those vertical asymptotes or those vertical borders. So that's wrong. This is correct. Now let's look at another example here. Let's try to graph this tangent function. Again, all we need is the period and the vertical asymptote. And we got to remember that the period is pi over b. So let's write that down. The period, again, is pi over b, or absolute value of b. So now we have that the period of this function is pi over absolute value of b. But what is my b here? B is 1. There's always an imaginary 1 there. So pi over 1, which is just pi. Vertical asymptote, if we remember a formula, that's pi over 2b, which we have here. Pi over 2, absolute value of b. But we found that b holds a value of 1. So now this becomes pi over 2, absolute value of 1, which is just become absolute value is 1, 2 times 1, so that's 2. All right. All we got to do is find a vertical asymptote. Let's say that each square, or the 2 squares, that's pi over 2. So 2 squares to the left, that's pi over 2. 2 squares to the left, oh no, I'm sorry, 2 squares to the left, that's negative pi over 2. 2 squares to the right, that's pi over 2. That's where we have our vertical asymptotes. So I'm just going to select this tool to make it easy for me. So vertical asymptotes, it happened at this graph, at this points. Well, that was way easier. So we got our vertical asymptotes there. So now let's actually graph the line. So passes through the origin. You gotta remember that your graph kind of touches there. It doesn't pass quite yet, and then it moves to the other side. Well, I mean, and what's the whole purpose of to find the period of the function? Well, because if we add these two intervals, we're gonna get exactly the period of the function. Because here we have pi over 2. Here we have pi over 2. And pi over 2 plus pi over 2 gives you 1 whole pi. So right now we're just sketching. We're not going too much into detail. I just wanted you to get exposed with the figure. How does a tangent function look like? So here's your entrance ticket. Try to graph the following tangent function.